When Pluto was reclassified as a dwarf planet in 2006, many believed it was just a lifeless, frozen rock at the edge of the solar system. But recent declassified images from the James Webb Space Telescope have turned that assumption on its head. What these photos reveal is more than extraordinary, it's downright terrifying. Pluto's icy heart, once thought to be a serene landscape, may be hiding a secret that has left scientists baffled. What could be lurking beneath its frozen shell? And why does this discovery challenge everything we thought we knew about our solar system? One of Pluto's most iconic features is its heart-shaped glacier, Sputnik Planitia, a region so massive that it has reshaped the dwarf planet's orientation. But what lies beneath this icy surface is even more fascinating and potentially ominous. Scientists now believe that under this glacier exists a hidden ocean of liquid water, insulated by a thick layer of nitrogen ice. This isn't just any ordinary ice field. It's an active, dynamic system with patterns of convection moving and churning like a frozen lava lamp. What could be fueling this activity so far from the Sun? Radioactive decay in Pluto's core may be generating enough heat to keep this ocean from freezing solid. But the presence of water raises an even more profound question. Could life exist in this frigid, alien environment? Pluto isn't the static, frozen world we once imagined. Declassified photos reveal massive tectonic features suggesting that the dwarf planet is geologically active. Cracks and faults indicate that Pluto's crust is flexing and moving, an extraordinary phenomenon for a world so distant from the Sun. The massive glacier has even caused Pluto to shift its orientation, aligning itself with its largest moon, Charon, in a gravitational dance that defies expectations. This level of activity raises chilling questions. What forces are at work beneath Pluto's icy exterior, and could they point to something far more sinister? The discovery of a subsurface ocean on Pluto is not just surprising, it's groundbreaking. Water is a critical ingredient for life, and its presence forces scientists to rethink the boundaries of habitability. If life could exist on Pluto, it could exist in countless other icy worlds across the galaxy. But Pluto's ocean is different. Shielded by miles of ice and bathed in perpetual darkness, any life here would need to adapt to extreme conditions that might produce organisms unlike anything we've ever seen. Renowned physicist Brian Cox has suggested that even the simplest microbial life on Pluto would redefine our understanding of life in the universe. But what if the truth is even stranger? What if Pluto's ocean isn't just a cradle for life, but a harbinger of something far more ominous? The James Webb Telescope has detected unusual thermal patterns and chemical anomalies that hint at processes we don't yet understand. These compounds, often associated with biological activity, have raised concerns about what might be thriving beneath the ice. Could these be signs of simple microbes or something far more complex, possibly even hostile? The possibility of advanced resilient organisms adapting to such extremes raises unsettling questions. Could life on Pluto represent a form of survival so alien that it challenges our very concept of biology? Pluto's potential ocean might be the result of a violent birth. Recent studies suggest that Pluto formed rapidly and chaotically, with massive collisions generating enough heat to create a liquid ocean. Over billions of years, radioactive decay has kept this ocean from freezing, but at what cost? This fiery beginning might have sown the seeds for a cold, enigmatic world teeming with unknown potential or hidden dangers. As scientists unravel these mysteries, one thing becomes clear: Pluto is not just a frozen relic of the Kuiper Belt. It's a dynamic, complex world with secrets that could change everything we know about life in the cosmos. Pluto's surface isn't its only enigma. The James Webb Telescope has also revealed striking details about the dwarf planet's thin atmosphere, unlike anything found on Earth. Composed primarily of nitrogen with traces of methane and carbon monoxide, Pluto's haze is produced by complex chemical reactions in its upper atmosphere, driven by the weak sunlight that reaches this distant world. These reactions result in the formation of organic molecules known as tholins, which give Pluto its reddish hue. But the presence of tholins raises an unsettling question. Could these molecules be precursors to more complex organic compounds that might, under the right conditions, support life forms adapted to extreme environments? Pluto isn't alone in its journey through the Kuiper Belt. Its massive moon, Charon, plays a crucial role in shaping its mysteries. Together, Pluto and Charon form a binary system where their gravitational pull influences each other in ways unseen elsewhere in the solar system. Charon's surface features mirror the complexity of Pluto itself, with massive canyons and tectonic activity suggesting a dynamic history. The red polar cap, likely formed from methane escaping Pluto's atmosphere and freezing on Charon, hints at a strange and interconnected relationship between these two worlds. Could Charon be influencing the activity beneath Pluto's surface? And what does this interdependence mean for the possibility of life, or other unexplored phenomena, within this binary system? Pluto is just one member of the Kuiper Belt, a region teeming with icy worlds and fragments left over from the solar system's formation. As our understanding deepens, one thing becomes evident. The more we uncover about Pluto, the more it challenges our assumptions, not just about a distant planet, but about life itself. Pluto stands out among the many objects in the Kuiper Belt. Its unique characteristics set it apart from its mostly static and inert neighbors. While other distant worlds remain frozen and lifeless, Pluto is alive with dynamic activity, from shifting ice fields to a thin but complex atmosphere. This raises a compelling question. Could similar hidden processes be occurring on other icy bodies in the outer reaches of our solar system? The discoveries on Pluto may just be the beginning, offering a potential roadmap to uncover the hidden dynamics of these distant, frozen realms. The revelations from the James Webb Space Telescope have opened a fascinating new chapter in Pluto's story, yet they've also raised more questions than answers. To truly understand this icy enigma, we'll need missions capable of exploring both its surface and subsurface in unprecedented detail. NASA's New Horizons flyby in 2015 provided a groundbreaking first look, but future missions must go deeper, probing Pluto's suspected subsurface ocean, analyzing its dynamic atmosphere, and investigating the chemical signatures that hint at possible life. With advancing technology, humanity is now closer than ever to unlocking Pluto's secrets and understanding its place in the broader narrative of our solar system. Could this small dwarf planet hold answers to some of the biggest questions about life, planetary evolution, and the mysteries of the Kuiper Belt? One of Pluto's lesser-discussed enigmas is the possibility of a magnetic field, a phenomenon that could dramatically change our understanding of its behavior and potential for habitability. While direct evidence is still lacking, scientists have detected anomalies suggesting magnetic activity beneath Pluto's icy crust. On Earth, our magnetic field plays a vital role in protecting the planet from solar radiation and maintaining a stable atmosphere. Could a similar mechanism exist on Pluto, shielding its subsurface ocean and atmosphere from the harsh environment of the Kuiper Belt? If confirmed, such a field could explain some of the unusual thermal and atmospheric patterns observed by the James Webb Telescope and provide crucial insight into how distant icy worlds maintain such active systems. Pluto's location at the far edge of the solar system also exposes it to forces not felt by inner planets. From the gravitational influence of its moon Charon to subtle yet significant interactions with neighboring Kuiper Belt objects, these external forces may play a key role in shaping Pluto's behavior. Some scientists theorize that periodic gravitational tugs from nearby bodies could generate internal heat within Pluto, helping to sustain its subsurface ocean and surface activity. These interactions also suggest that Pluto may have experienced close encounters or even collisions in its ancient past, events that left lasting marks on its surface and perhaps contributed to its present complexity. Far from being the cold, lifeless rock it was once assumed to be, Pluto has proven to be a world full of surprises. The declassified images from the James Webb Telescope have unveiled a planet of dynamic glaciers, a mysterious atmosphere, and the tantalizing possibility of a hidden ocean beneath its icy surface. This remote dwarf planet challenges everything we thought we knew about what a planet can be, reminding us that even in the most distant, frigid corners of the solar system, there is motion, transformation, and perhaps even life. These discoveries push us to ask deeper questions. Could Pluto's hidden ocean support life? What do its tectonic features reveal about the processes shaping icy worlds across the cosmos? And what other secrets are waiting to be uncovered in the vast and shadowy Kuiper Belt? Pluto is not just a relic of the solar system's past. It's a window into the dynamic processes that govern planetary systems and perhaps even the evolution of life itself. As we look to the future, the tools we build and the missions we launch will bring us closer to unraveling Pluto's mysteries. What do you think lies beneath Pluto's icy crust? Share your thoughts in the comments and subscribe for more cosmic discoveries. The journey to understanding Pluto is far from over, but one thing is certain: this frozen world has sparked a fire in our imagination, urging us to keep exploring, keep questioning, and never stop reaching for the stars. Until next time, stay curious and keep looking up.